The following is for 2008 Math 125 Department Final. In this video, I will do number 25 and number 26. Number 25. Solve the system of linear equations below. Now we have a system of three equations with three variables, and they are all linear equations. What I will do is the following. Let me assign first. I will name them first equation, the second equation, and the third equation here. What I will do is I will pick two different pairs of equations from here and eliminate one variable. When I eliminate one variable, I will eliminate the same variable. Okay, now let me start. Let me first choose the first pair, equation 1 and equation 2. And I will have this system 2x minus 3y plus 4z equals to 14, and 4x plus y minus 3z equals to negative 5. Now I will eliminate a variable right now. The variable that I choose to eliminate right now will be the same variable that I will need to eliminate for another pair later on. Okay, now let me choose to eliminate the y. So here I will multiply by 1, and here I multiply by 3, so that the coefficients will be opposite coefficient. 2x minus 3y plus 4z equals to 14, and then here I have 12x plus 3y minus 9z equals to negative 15, which if I add them, it will be 14x minus 5z equals to negative 1. Now let me call this equation 4. The second pair I will use is equation 2 and equation 3. Now it doesn't have to be equation 2 and equation 3. It doesn't have to be equation 1 and 2, but they have to be different pairs. Okay, you may use 1 3 and 2 3, or you may use 1 2 and 1 3. No, I mean it has to be different pairs. Okay, now but you need to eliminate the same variable. Now let me see. Second equation, third equation, 4x plus y minus 3z equals to negative 5, and then the third equation, 3x plus 2y minus 2z equals to negative 3. Now I want to eliminate y again, right? Because earlier we eliminated y. Now here I will multiply this by negative 2, and the one here I will multiply by 1. This way they will have opposite coefficients for the y. This is negative 8x minus 2y plus 6z equals to 10. Here I multiply by 1, which means I basically copy them down. Now I add them. I get negative 5x plus 4z equals to 7. Let me now call this equation 5. Now once I have this equation 4 and 5, so notice this, by doing these two pairs right now I have a new system of equation, but this time only two equations with two variables. Okay, equation 4 and equation 5. Right now it is from three equations with three variables. Now I have two equations with two variables, x and z. Okay, now then from here we will choose to eliminate one of the variable. I think I will eliminate z. And so here I multiply by 4, and this one I multiply by 5. This will be 56x minus 20z equals to negative 4, and the one here will be negative 25x plus 20z equals to 35. When I add them, this becomes 31x, and this one will be 31. It implies x equals to 1, right? Now what I will do then is to use this x and plug it into either one of these equation here. For example, let me choose to plug it into equation 4. If I plug it into equation 4, then 14 times 1 minus 5 times z equals to -1. 14 equals to 5z. 14 minus 5z equals to -1. -5z equals to -15. Therefore, z equals to 3. Okay. Actually, at this point, you see the x equals 1, the z equals to 3. We already know that it will be 1 comma something comma 3, right? And that implies the answer will be E. Okay, but to confirm, let's plug this number in. I already have x and z. I will now plug it into either one of these equation 1, 2, 3 here, either one of them. I think let me put it into the first equation, or maybe the second one. Let's put it into the second one. It'll be 4 times 1 plus y minus 3 times 3 equals to -5. That's 4 plus y minus 9 equals to -5. Y minus 5 equals to -5. Therefore, y equals to 0. Right? That confirms that my y equals to 0. Okay, if I draw the line, this x is 1, right? And then the z is 3, the y is 0. Okay, now this is for number 25. Now I hope you are not lost in details. The plan is actually this. I try to use these 3 by 3 equations, 3 by 3 system, 3 equations with 3 variables. I choose 2 different pairs and eliminate the same variable, such that after that I get a system of 2 equations with 2 variables. From here then, I do elimination process again, that I get x equals to a number, okay, one of the variable with equal to a constant. Then I plug it back to either one of those 2 equations, and I solve for the other variable. Okay, using these 2 variables now, I plug both of these back into either one of the original equations. Now that way I get the last variable. Okay, that's how we get it. Now that's for number 25. Let's move on to number 26. Solve x equals to this if possible. X equals to square root of 44 minus 7x. Now what I will do first is to undo the square root by squaring both sides. If I square both sides, I will get x squared on the left hand side, and the right hand side will be 44 minus 7x. Maybe to be more precise, you see it this way. Okay, and it will be x squared equals to 44 minus 7x. Now then this becomes a quadratic equation, which I will set one side to be 0 and factorize whenever possible. In this case, it will get 11 x equals to, x plus 11 and x minus 4 equals to 0. Now we get x1 equals to -11, x2 equals to 4. Okay. Now you may wonder why we don't have -11 in the solution there. Let's see. That's because every time you square an equation, you need to check the solution. First, I check x1 equals to -11 against the original question. Okay, -11 is equals to square root of 44 minus 7 times -11. Now notice something is clear right away. Square root of anything will be positive or 0. It will not be negative. Okay, but to confirm what we thought earlier, this will be 44 plus 77. There will be square root of 121, which is positive 11. Okay, so you can see here that -11 is not a solution. Now let's check x equals to 4. It is possible that x equals to 4 is not a solution either. Okay, so if you have 2 possible solutions here, you need to check both of them. If you have 3, then you need to check all 3. It is possible that you have no solution at all. It is possible that you have only one solution. It is possible that both of them are solutions. Okay, now in this case we know that negative 11 already taken down, right? But let's see what happened with when x equals to 4. 4 equals to, is it equals to square root of 44 minus 7 times 4? Is it equal to, is 4 equals to square root of 44 minus 28? 4, is it equals to square root of 16? I believe that's correct. Okay, so now we summarize. So x equals to 4, which means the answer is B. Okay, this is from Fall 2008 Math 125 Department Final, number 25 and number 26.